About lesson 7.4, properties of natural logarithms. So we started talking about logarithms last week. Today we are looking at properties, and there are 4 properties that you see here that we're going to be talking about, and these properties are what we're going to use really throughout this section and 7.5 and 7.6 to help us solve equations and evaluate stuff and just whatever it is. So looking at these 4 properties of logs, So we have the product property. And as you look at the product property, you will notice it says log base b of mn equals log base b of m plus log base b of n. So what that's saying, so first of all, product of course means multiplication. So this one is, the short of it is saying if you have a log that has multiplication within it, it can be separated into 2 logs being added. So for example, the log of base 6 of 8 plus log base 6 of x, when you add those, take the 8 and the x and multiply, and it's log base 6 of 8x. Now keep in mind, in order to use the product property, the base has to be the same. Okay, you can't have 2 different bases happening here. But other than that, just 2 logs being added with the same base can be rewritten as 1 log where the insides are multiplied. That's the product property. Now, we also have the quotient property. Same thing except with division and subtraction. 2 logs being subtracted can be rewritten as 1 log where the insides are divided. Log base b of m divided by n equals log base b of m minus log base b of n. So the example over here, log base 2 of 8 minus log base 2 of 3, 2 logs being subtracted, can be rewritten as log base 2 of 8 divided by 3. The next property we have is the power property. And if you notice the power property, log base b of m raised to the power of n, says that this power can be moved to the front. And you'll notice here it's written as n times log base b of m. So whatever number or values in the exponent can also be moved out front and written as what I would call a coefficient. So for example, log base 2 of x squared, well, you can take this power of 2 out front, and it could be rewritten as instead as 2 log base 2 of x. And that's called the power property. It can go back and forth in between being a number out front, so a coefficient, or an exponent. And then lastly, we have the identity property. The identity property says log base b of b. What do you notice? The b's are the same. So log base b of b equals 1. So when the base and the inside base of the log are the same, the log will just equal 1. So the example here, log base 2 of 2 equals 1. We could say log base 9 of 9, and we would know it equals 1. Log base 1,000 of 1,000, and it equals 1. Now, we also have a slight variation on this identity. Now, log base 2 of 8. Notice 2 and 8 are not matching, but we know according to our gold paper that 8 is the same as 2 to the 3rd. And if you rewrite this here, log base 2 of 8 can be rewritten as log base 2 of 2 to the 3rd. Notice these 2's are matching, right? So if the 2's are matching, this log is just 1, but since there's a power of 3 that could be moved out front, it's 3 times 1, or in other words, 3. The easiest thing to note is that if you have the log, these 2's match, your log is going to be equal to whatever your power is. So here the power was 3. Here, log base 2 of 2, what's the invisible power? It's an invisible power of 1. So those are the 4 properties that we're going to be using. And as I said today, it's a lot of just practice of going back and forth between them. Okay? So, and by the way, do you guys have your gold papers available today? You won't need a calculator as far as we get in the lesson, But I would encourage you to have your gold papers because we will refer to those a couple of different times. So let's look at example 1 here. And example 1 says, what is each expression written as a single log? In homework or on a test, I can't remember exactly how it's written, but you might see it written as being asked to condense each log. So take these multiple logs and shrink them down to just one. So log base 4 of 32 minus log base 4 of 2. Any thoughts of how I could use one of those properties from up above to get me started? Reese, what do you see?
Quotient property.
The quotient property. Okay? The quotient property up above says 2 logs being subtracted can be rewritten as 1 log where the insides are divided. I was just getting ready to bring you a new gold paper back there. Okay. I did. I was like, I'll just give her a new one, but you found it. All's good. Okay, so quotient property. Log base 4 of 32 minus log base 4 of 2 can be rewritten as 1 log. So we're going to rewrite this as log base 4. And since it's subtraction, the insides are going to be what? Divided. So log base 4 of 32 minus log base 4 of 2 is equivalent to log base 4 of 32 divided by 2. You guys have been doing math long enough. Do you think I get to leave it like that?
I hope. Just to say it simplifies, so yes.
But we always simplify math. That's just understood. What is 32 divided by 2? 16. So now we have log base 4 of 16.
Oh, look at that. Now we're going to have to do stuff. Not just the equal line.
We don't need to go that far. We have our new properties now. Okay, so Ezra's thinking we're going to have to do stuff. I agree. Think for a moment, okay? It's log base 4 of 16. I said have your gold papers available, right? What do you know about 16? And I don't even know if you need your gold paper for that one. But 16 is 4 squared, yes? Technically, if you really wanted to, 16 is also 2 to the 4th. However, which one is more helpful here? Yeah, because this base is already 4, it would be better to use the 4 squared. So we could rewrite this as log base 4 of 4 squared. So anytime you see a number today that's on your gold paper, use that gold paper. Now, there's technically one last step we can end up taking. So that identity property up above that some of you are starting to hit on. What do you notice? These 4s are matching, right? If the 4s match, well, what happened up here? The 2's match. Log base 2 of 2 to the 3rd equaled the exponent of 3. What does log base 4 of 4 to the 2nd equal? The exponent of 2. So all of that to say, log base 4 of 32 minus log base 4 of 2 ultimately simplifies down to be 2.
I'm never going to put 2 in that. I'm like, oh, you solved it. This is what you went to school.
Okay, so this is how we're using the properties today to simplify things as far as we can. Questions on this one? Okay. Let's continue on to B then. 6 log base 2 of x plus 5 log base 2 of y. Any thoughts on a step we could take? Because there's several that we're going to take, I'll be honest. But steps on what property you think we could use first? Sierra? We can't, hold that thought. We're going to use the product property, but I can't use it quite yet. There's something else I have to do first. Reese?
Power property.
What's the power property do?
It must be 6, 5.
Okay, so here's the deal. As much as we want to, we can't use the product property and put these together yet because they have numbers out front, because this 6 and this 5 are out front. So we first have to deal with the 6 and 5, which is the power property, and then we'll go back and use the product property. So power property says a number out front like this 6 can be written as the power. Same thing with the 5. A number out front like the 5 can be written as the power. 6 log base 2 of x can be rewritten as log base 2 of x to the power of 6. Good. Plus 5 log base 2 of y can be rewritten as log base 2 of y to the 5th. Now that they are both just log base 2's, okay, we don't have anything extra thrown in there, now we can use the product property. Product property says when 2 logs are being added, it can be rewritten as 1 log where the insides are multiplied. So I'm going to rewrite this as log base 2 of, what is x to the 6th times y to the 5th? Okay, good answer. X to the 6th, y to the 5th. I am going to put parentheses around that x to the 6th, y to the 5th. Just the more you get inside a logarithm, you're going to want parentheses just indicating, yes, this is all inside the logarithm. Anything else to do with this problem?
With it, with the parentheses, it kind of feels like it's not part of the logarithm.
Well, but it is because the 2 is the base, so there has to be something inside the logarithm, and that's what it is. If you don't put the this one's kind of borderline. It's just if you don't put the parentheses, it becomes okay. X to the 6th is inside the logarithm, but is y to the 5th, or is that being multiplied? You know, just something you have to be careful of. In this case, because x and y are variables, we can't do anything mathematically with them because they're not numbers. We are actually done here. We can't go any farther.
Trying to do other things.
That's kind of good in a way. I've got you trained to keep looking, not just stop so easily. So, okay, let's try C. Log base 4 of 5x plus log base 4 of 3x. What do you see, Sarah? What? I know you meant. Oh, wait.
Or the power property, not product.
Wait, which one are we talking about? Power or product property?
She wants to use the vote. Both at the same time.
Okay, well, the power, in order to use power property,
It has to be at the beginning.
there has to be a number at the beginning. Do we have any numbers at the beginning?
We have 1.
We don't have any numbers out front of the logs. So if we don't have any numbers out front of the logs, these logs that are being added are ready to be put together. 2 logs being added can be rewritten as 1 log where the insides are multiplied. So log of 5x plus log of 3x can be rewritten as log base 4 of 5x times 3x. So we got to go straight to the product property. Can we multiply 5x times 3x? Okay, we should. What is 5x times 3x? Log base 4 of 15x squared. Is this pin being difficult?
Because it's dying blue.
It appears to be, but there's plenty of ink in this one. Okay. Anything else?
I'm going to say no.
Oh, she lied.
God is good on that one.
I didn't circle it, but just because I want you guys to think.
I'm still waiting for her to circle something to pull up the white out.
Okay, so on that one we are done. There wasn't anything else we could do. Okay, D. 2 log base 4 of 6 minus log base 4 of 9.
Okay, I have a question before I say the property.
Okay.
Can you only use like the property or
I think you're right then.
Let's use the power product.
So which property are we starting off with?
Can I have power for 50, please?
Okay, power property, because on the first one, we do have a coefficient out front, right? We can't leave this 2 out front. We don't need to use the power property on the other one. That's fine. We're just going to use it on this one. So what do we do with this 2? Make it part of the power. So 2 log base 4 of 6 is going to become log base 4 of 6 to the second. What is 6 to the second while we're here? 36. So I'm going to write this as log base 4 of 36. And then don't forget, we still have log base 4 of 9.
Because technically you still use power on that, so there would be a 1 in front of log, and you just put 1 above that.
Sure, you could think that way. Okay, so we use the power property. Now what? Okay, 2 logs being subtracted can be rewritten as 1 log where the insides are divided, and that is our quotient property. Log base 4 of 36 minus log base 4 of 9 is log base 4 of 36 divided by 9. What do we know about 36 divided by 9? It's 4. So now I have log base 4 of 4. Which equals 1. Identity property said if the base and the inside are the same, it's just equal to 1. If there was a power up here, it'd be equal to the power. But in this case, it's just equal to 1.
We should start giving her equations to solve our equations, but instead of actually putting this number 1, putting that down. Putting that whole equation down.
Putting the entire equation down.
Okay.
You know how we feel.
Questions on this one? Okay. So all of example 1, they asked us to write them as a single log. As I said, you might see it ask you to condense, okay, into 1 log. Example 2, we're going to go the opposite way. This time they're giving us 1 log, and our job is to use our properties to expand it. So pull it apart using the same properties, writing it as multiple logs where necessary. So as we look at A here, log of 4x over y. Thoughts on how I can start this? And my question is going to be is, what do you see in that log?
I see a 4x over y. That's the quotient.
Okay, you see a 4x over y, which means you're seeing a fraction or division.
And there's no number.
So we can talk quotient here. Log of 4x over y. One log where the insides are divided is going to be rewritten as 2 logs being subtracted. So log of 4x minus log of y. And I don't know if I'm the only one guilty of here. Be careful how you write your g's and your y's. I'll be honest, my g's and y's tend to look a lot alike if I'm not careful. And it must just be how I draw them, because some people's look completely different, some of them look similar. Now, I'm looking for another step. What's another property that we could use somewhere in here?
You can use the power. It has to be frontage, right?
Okay. I don't see any powers to use the power property, but do you see a product? What do you know about 4x? 4x is 4 times x, right? So that is 1 log where the insides are multiplied, which means I can rewrite this as 2 logs being, what are they being done? Added. So log of 4 plus log of x, and still minus log of y. Now, I'll be honest, this is one of the answers I have circled as a possible answer in my notes. However, there's also one more step that we could take, if you can see it. And my hint is for you to think gold paper.
So where's a 4 on this paper?
2 squared.
And the key is, 4 is the only number in this problem. So it does become, where is 4 on the paper? So log of 4 is log of 2 squared. What can I do with that 2? The power of 2, that is.
Put it in front.
We can use the power property. And last step will be to write that 2 out front. No, because we're trying to expand it. So we can write this as 2 log 2. Don't forget we still have plus log x minus log y. Okay, so these expanding ones, you want to look for as much expanding as you can. Okay? Now, you will notice I ran into the next problem just a little bit. This is bad setup. I can't get all of them into across here. So what I'm going to do, this pen is not cooperating. I'm going to take this next one and put it down below. And that way I have room to write it. Now, what do you see? Division means I can rewrite this as log base 9 of x to the 4th minus log base 9 of 729. Division inside a log can be rewritten as 2 logs being subtracted. Ooh, that's what's already been looking. 729. It's on that gold paper. Log base 9 of 729. 729 is 9 to the 3rd. What do you know about log base 9 of 9 to the third?
That's not where.
These two 9s are the same, so log base 9 of 9 to the third equals 3. When those 9s are the same, it equals the exponent. One last piece. Log base 9 of x to the fourth. What should I have done here? Take the 4 and put it where? Out front. So it's 4 log base 9 of x. That one's an x. There's not anything else you can do with that. So 4 log base 9 of x minus 3 for the final answer.
Do you think that we would need the log not make it 3 bigger? That's what I did.
Hi there, can all students please stay in your classroom at this time? You will be released in a minute.
Well, come on now. I've got places to be. I'm a very busy man.
It's summer class.
Okay, guys. If you would, for Monday or for tomorrow, you can start working on the homework, but you don't have to finish it. We will finish the notes tomorrow.
Do we have